No, the video camera is good. I only have something you need. And
Pressure pushing down on me, pushing down on you. No matters for under pressure.
So to see how much it weighs, what I'm going to do is I'm going to put it down on a scale. Just, the more bathroom scale, nothing too fancy. Bathroom scale that is dripping all over the place. Let's make it stay a little tighter. So here's our scale. Stop moving. So we'll just put the glass right down on the plate. And then let's see what it weighs. I think you can kind of see there. Looks to me like about 10 pounds? Yeah, okay, roughly. So we have a 10-pound piece of glass. So you probably think, well, it takes 10 pounds to lift a 10-pound weight. Well, actually, we're going to do it differently from usual. We're going to use air pressure to do it. But we have to understand something about air pressure. So let me introduce you to one of my favorite props. Went down to Valley Iron, just down the street from you guys, and I bought this really long bar. Now this bar is 1 inch cross-sectional area. And I don't know how long it is, but it's long enough so it weighs, well listen. So now I'm going to take this bar, this big bar, and I'm just going to rest it vertically. You have to trust me here. Vertically on the scale. And it looks like it's pretty close to 15 pounds. I mean, this is a funky bathroom scale, but it actually weighs 14.7 pounds. But I'm going to call it 15 because it's easier math. So, 15 pounds per square inch. 15 pounds per square inch is air pressure. Now you might think, wait, I put 30 pounds in my car. Well, no, you don't put 30 pounds in your car tires. If you did, your cars would be, with 4 tires, your car would weigh 120 pounds more. So you get 30 pounds per square inch. It's pressure, it's not weight. But pressure is weight divided by area, as in 15 pounds weight per square inch divided by area. So what we're going to do here is we're going to try to lift this guy, and we're going to lift it using air pressure. So let's take a look at this guy here. So this thing is, just a disc made courtesy of California industrial rubber. It's really nice quality gum rubber. I've sort of made this funky holder on the back end here. And now we're going to find out, since pressure is pounds per square inch, to see how many square inches this guy is. Okay, now everything is kind of be loose and sloppy here because I don't want to worry about the details. Air pressure is 15 pounds per square inch. And this bar, which is 1 square inch cross-sectional area, weighs 15 pounds. That means that every square inch of me, like my hand, has 15 pounds pressing on it. I mean, come on, that is so crazy. How could that be? I mean, wouldn't that hurt? I mean, think about fish at the bottom of the Mariana Trench. It's like 35,000 feet deep in the bottom of the ocean. I mean, the pressure on them is just unimaginably high. So how come they don't get squished? Well, simple. All they have to do is swallow a little bit of that 35,000 foot deep water pressure inside their body, and then the pressure pushing out is equal to the pressure pushing in. So just like there is 15 pounds right there, 15 pounds per square inch pressing on my hand. Well, guess what? On the other side of my hand, there's another inch, and that inch has the exact same 15 pounds per square inch. And so I don't get pushed either way. Now, if you took away one of those two pressures, then you'd have a lot of force involved. And that's exactly what we're going to do with this guy. So this is a little, California industrial rubber sheet, and it's about 8 inches in diameter. So let's figure out, since pressure equals weight or force per area, let's figure out what the area of this guy is. So it's pretty basic. Okay, you have a circle here, and that circle is 8 inches in diameter, which means 4 inches in radius, yeah, okay. So if that's 4 inches, and the area of any circle is just pi r squared, well, that's, we can do this. So pi is 3.14, let's call it 3. And let's just do a squiggle here, so it doesn't really matter if it's exact. So 3 times, and that's 4 inches squared, and that's 16. So 3 times 16, that's about 48. That's exactly 48. So I can say it's about 50 square inches. Yeah, 50. That's okay, because if it was like 7 by 7, it'd be 49, and it's 8 and then round, so 7 by 7 would be 49, so about 50, yeah, roughly. So that means every one of those square inches, and there's a heck of a bunch of them, every one of those square inches has 15 pounds pressing on it, on one side and on the other side. So if we were to take away one of those 15 pounds per square inches on this side and still have it on the other side, then, you know, that rubber would move. So let's take a look at what that would involve as far as the magic trick I'm about to show you, which is why I built this whole thing. So I have a nice big piece of glass here. 10 pounds, right? Yeah. Nice big piece of glass, nice glassy. And so what I'm going to do is I'm going to put our magic rubber right on there. Now, in case you're thinking, okay, he's one of these YouTube tricksters, and all he did was he just like put some, you know, what's it called? Crazy glue on there. Well, yeah, crazy glue, I don't think so. I mean, nothing is holding this thing on, right? Except air pressure is pushing down, but air pressure inside is pushing up. But if I try to lift this, then suddenly there's going to be a cavity inside there, and the cavity is going to have no air pressure because there's no air in there. Right now there's no air, there's just flat glass against flat rubber. So I lift this up to a cavity with no air pressure, and even if that cavity is pretty small, let's suppose it's like, I don't know, 3 by 3 inches. That's 9 square inches of nothing. Well, 9 times 15 is, what's 9 times 15, 990? That's 145. So 145 pounds will not be pushing down here, but 145 pounds will be pushing up from underneath, right? See? So that means that if I lift this thing up, air pressure is actually going to be the thing that's lifting it. So let's give it a try. Are you ready? 1, 2, 3. Can this really be? Oh yeah, baby. And you might think, oh, he's faking it. Well, actually, no, just let some air underneath there, comes right up. So, thank you, California Industrial. Let me get this thing. I can't even pick it up to show it to you. Thank you for donating this to educational purposes. I'm going to have a great time with this guy. In fact, if any of you wanted to play this trick on your friends or family, it's easy. I mean, the trick was figuring out a glue that would glue this plexiglass to the back. I used E6000 and it holds pretty well. This is just a cheap, you know, cordless drill chuck. But you don't have to use that. But anyway, something just to hold it. And it's way better than I thought it was going to be. I mean, it's magic. So enjoy, and thanks for watching.